Alright, so this is our question number 3. I hope you are staying tuned. You all have solved question number 1 and 2 along with me. This is question number 3 on the topic dynamics, Newton's laws of motion from your AS Physics past paper practice questions. So here you have the question. It is a question not so long. It fits on one screen. Pause the video, try to attempt the question yourself, play the video again to look at the working of it. Alright, so I hope that you are back. You are playing the video again to look at the working of this question. State Newton's first law. This is a question. This is a kind of a question which was something which you practiced in question number 1 as well. Newton's first law, second law, third law, stating them in words is a very common question. It keeps coming, repeating year after the other. So please, I would request, take out some 15 minutes of a time during the day or during any time whenever you are free and practice talking about them, because you can be ultimately very sure that one of the questions will definitely come in the exam on these, right? So how do you define Newton's first law? A body or an object or a mass will continue to stay in the same state of motion until a resultant force acts on it. What does it mean? If an object is moving at a constant speed, it will keep moving at the constant speed forever and ever until a force acts on it, resultant force acts on it. Similarly, if you have an object which is at rest, it will stay in the same state of rest until you push it, pull it, or you apply a resultant force on it, right? So the theory for it is there on the channel. Please explore through the channel, find the theory and understand the theory of it. The mark scheme also expects you to write not so much because it's just a 1 mark question. A body continues at rest or a constant velocity unless acted by a resultant external force. Simple and easy. Alright, let us come to the B part. A log of mass 450 kg is pulled up a slope by a wire attached to a motor. So this is the wire. There is a motor which is pulling the log up. The angle that the slope makes with the horizontal is 12 degrees. The frictional force acting on the log is 650 newtons. The log travels with a constant velocity. Velocity is constant. It should give you some hint. Where does this hint come from? This hint comes from something which the question asked you to state just now. So it is a hint. This is a question which initiated some memories about physics in your mind. What did you understand? If an object is moving at a constant velocity, it will keep moving at a constant velocity. Why? Because the resultant force on it is 0. Same thing. The object is moving at a constant velocity. Why? Because the resultant force on it is 0. The constant velocity will change into an increasing velocity or a decreasing velocity, acceleration or deceleration only when the resultant force acts on it. Right? It relates to your Newton's first law of motion. The log is traveling at a constant velocity means acceleration is 0. Why is acceleration 0? Because the formula for acceleration says v minus u over t. Constant velocity means v will be equal to u at all point of time. Initial velocity, final velocity, they are all the same all the time. Velocity is constant throughout. So the numerator becomes 0 because the terms in the numerator v and u are same. Acceleration is 0 meters per second square. Constant velocity means acceleration is 0. Now let us come to the first part. With reference to the motion of the log, discuss whether the log is in equilibrium. So if you come to the concepts of moments, when do you say that an object is in equilibrium? When the resultant force is 0 and the resultant moment is moments and resultant force is 0. 2 mark question. How do you prove that resultant force is 0? Because resultant force is, the formula for resultant force is ma, and a is 0. So this is 0 because we know that acceleration is 0. Resultant force is 0. Resultant moment is 0. Why do you say that? Because when you look at the situation itself, by the look of it, you do not see any turning happening for the log. It is just moving in a straight line. Is it turning, rotating? Is there any pivot around which this log is turning around? No. Just mention that the log is not turning. It is moving in a same straight line. So therefore, no moment. Moment means turning effect, right? So simple. How do you say this? 2-mark question. You say that the resultant force is 0 because acceleration is 0. Acceleration is 0. Why? Because it is a constant velocity. First point done. Second point, you say that the resultant moment is 0. Why? Because there is no turning. Go through my video on equilibrium on the topic moments. You'll understand how to define equilibrium. There is a separate video on equilibrium. Alright, let us refer to the mark scheme as well. Constant velocity 0 acceleration, therefore no resultant force. No resultant force as well as no resultant torque. Torque means moment. Hence it is an equilibrium. 2-mark question. You get full 2 marks. Go through my video on equilibrium. You'll understand how to solve these questions. Calculate the tension in the wire. Okay. So constant velocity means all the forward forces should be equal to all the backward force. How much is the forward force? Let us call it T. Tension. Tension, what is the tension? Tension is a kind of a force which occurs in a wire or a string or a rope. So pulling force by the wire, string, thread, rope, it is called tension. That's the definition of tension. Are there any other forces acting on the log? It says that there is a frictional force on the log. Let us mark this as well. The frictional force, which is 650. Let us mark this. This is your 650 newtons, which is friction. Let us call it FRI, friction. 650. Is there any other force acting? There is a weight acting downwards, mg. What is the component of mg in the downward direction? Component of mg in the downward direction is mg sine 12. Right? If we talk in terms of the forces acting down the inclination, along the inclination, let us make the resultant force as 0. Resultant force has to be 0, right? This is what I have proved because the velocity is constant, and for it to be 0, tension should be equal to frictional force, Fri friction, plus mg sine 12. Let us substitute the values. Friction is 650. How much is the mass? 450. This is the mass given in the question. Times g is 9.81 times sine of 12. Solve this please on your calculators, and let us also see at the mark scheme. You can pause the screen here for a moment, do your calculations on the calculator and see if you are getting this answer. They have done the same thing. Your answer should be around 1570 on your calculators, or 1600 when you round it up to 3 significant figures. So let us carry on with 1570. 1570 newtons. If we say 1570 newtons, it's 100% correct, right? Do not worry about it. Okay, last part. State and explain whether the gain in the potential energy per unit time of the log is equal to the output power of the motor. They are saying that as the log is going up, is the gain in the potential energy due to the gain in the height equal to the output power? Is the motor only working to increase the height? No. The motor is also working to overcome, the motor is also working to overcome friction. Just hold on, let me change the color here for the text. You say that the motor is also working to overcome the frictional force. So it will have to produce more power than the gain in potential energy of the lock. There is a, how do you explain it in terms of the formulas? Power output by the motor, should be equal to the potential energy gained plus the work done against the friction. If you see, potential energy is not same as power output by the motor. Power output by the motor has to be much more than the potential energy produced. Motor is also working to overcome the frictional force, so it will have to produce more power than the gain in the potential energy of the lock. This WD is work done. Here is the mark scheme. I hope that you have understood the question. Please do read the mark scheme and understand the mark scheme as well. And if you have any comments, any suggestions, or any good points that you liked about the video, please do comment in the comment box. It will be highly helpful and highly appreciative of me. And also please do not forget to subscribe to the channel. Thank you so much.